Hello everyone, welcome to this session. In this video lecture, we will solve some of the numerical problem on the principal stresses and also maximum shear stresses. So let us start with the one problem. The problem is a direct stresses of 160 MPa, tensile 120 MPa, compressive exist on two mutually perpendicular planes. The maximum or greatest principal stress at the point is 200 Newton per mm square. What must be the magnitude of shearing stresses on two planes and what will be the maximum shear stress at that point? So this is the problem. This problem belongs to whatever we have studied or seen the four different cases. So this problem belongs to fourth case, which includes the direct stresses acting in two directions, and also along with this the shear stresses are also acting on the planes. So here it is. This is a two-dimensional lamina. That's why one direction is x-axis, x direction, on which the direct stress is acting sigma x, and other direction is sigma y, that the stresses are acting in y direction. Along with this, shear stresses tau xy are also acting on the corresponding x and y plane. So in the problem they ask to determine what must be the magnitude of the shear stress. Means we have to determine the shear stress. Also we have to determine the maximum shear stress at that point. Means shear stress we determine and also maximum shear stress tau max. So first of all, write the given data. So sigma x value you can see in the figure. If the figure is not given, so from the whatever the description of the problem, you can draw the figure for your understanding, which will be helpful for the solving the problems. So now this figure is drawn as per the data available or as per the discussion, as per the description given in the problem. So sigma x, as you can see in the figure, which is positive, it is taken because there is a tensile in nature, and in the y plane there is a direct stress sigma y is acting, which is compressive in nature. That's why there is a minus sign. This value is minus 120 MPa. Along with this, there is a greatest principal stress at the point is given 200 Newton per mm square, and tau xy we have to determine. Along the xy plane, shear stress we have to determine. First of all, we have to start with the relation maximum principal stress, and the symbol we consider as a sigma p1 is given by sigma p1 is equal to sigma x plus sigma y divided by 2. We have taken plus sign for the greatest principal stress. Sigma x minus sigma y divided by 2 bracket square tau xy square. So this relation we already knows for the case number 4, the direct stress acting on x and y direction and shear stress also. So let us put the values which is given in the problem. 200 for principal stress value is given. Sigma x value is 160 plus 160. Sigma y value is given minus 120, and only unknown is tau xy, that is the shear stress along xy plane. So if you put all the value and solve this relation, so you will get the value tau xy 113.137 MPa. So this is a shear stress along xy plane. As we know that tau xy value is equal to tau yx value. So this tau xy is same for the plane which is available on the x plane and on the y plane. Next one, maximum shear stress. So maximum shear stress value and the relation we knows that sigma p1 minus sigma p2 divided by 2 or you can also use the other relation, that is sigma x minus sigma y divided by 2 bracket square plus tau xy square, whose total root square of these two terms. So this relation, this above two relations, from this you can determine the maximum shear stress. So here it is, we have taken that second relation, sigma x minus sigma y divided by 2. So sigma x value is 160, sigma y value is 120 divided by 2 bracket square, and tau xy just we have determined 113.13 square. So if you solve these relation, because all the values are known and unknown is tau max, so from the after solving we will get the value 180 MPa, which is a maximum shear stress. So understood here that relation which is used for the determination of maximum shear stress. Next problem. For the stress condition on an element as shown in figure, determine the principal planes and the stresses. Also determine the maximum shear stress and the plane on which they act. So this problem description is given, and in this problem the figure is also mentioned, or it is given in the problem. So from the figure also you will get some values and some stresses and the shear stresses also. As per the figure, you can see on the x direction there is a tensile stress sigma x value is given, and in the y direction, y plane, there is another direct stress is acting, which is compressive in nature, whose magnitude is 75 MPa. Means sigma x is given along x plane is 40 plus 48 MPa. Sigma y is along y plane, which is compressive, that's why it is minus sign is taken, minus 75 MPa. And shear stress is also given along the xy plane, which is 14 MPa. So from this data you have to determine the sigma p1, sigma p2, tau max, that is the maximum shear stress, theta 1, theta 2 are the plane on which these principal stresses are acting. Means principal stresses are 2, sigma p1 and sigma p2, and principal planes are also 2, theta 1 and theta 2. So let us start from the principal stresses, theta sigma p1. So we have the relation sigma x plus sigma y divided by 2 plus sigma x minus sigma y divided by 2 bracket square plus tau xy square. So sigma x value is 48 MPa, sigma y is minus 75, tau xy is 14. So all this value if you put in the above relation of sigma p1, you will get the value sigma p1 is 49.57 MPa. This is one principal stress. Other principal stress you have to take a minus sign only, and if you put all the values of sigma x, sigma y and tau xy, so sigma p2 value after calculation you will get minus 76.57 MPa. So from this relation we have determined the principal stresses. After that, principal planes. So we know the basic relation of principal plane theta p. The symbol of the principal plane normally it is used theta p. P stand for principal plane and theta is the inclination or orientation of these principal planes. So 1/2 tan inverse of twice of tau xy divided by sigma x minus sigma y. So tau xy value we have determined, sigma x 48, sigma y is minus 75. So only just we have to put into this relation. So we will get theta p1 is equal to 6.24. This is one principal plane we got here. Another principal plane, of course it is a mutually perpendicular, that's why you have to add 90 to the theta p1. So you will get the total theta p2 is 96.24. So only the difference between these two planes is 90° because these two planes are mutually perpendicular on which these stresses are acting. One plane is major principal plane, another plane is minor principal plane, because on the one plane there is a major principal stress is acting, highest principal stress is acting, and in the other plane there is a lowest principal stress or low principal stress, or normally we call it as a minimum or minor principal stress is acting. After that, maximum shear stress. So maximum shear stress formula we knows that sigma P1 minus sigma P2 divided by 2, and also other relation that sigma x minus sigma y divided by 2 bracket square plus tau xy square. So from both these relation you can use one of the relation and you can find the maximum shear stress. So you can choose one relation for determining the tau max. So tau max value, after putting the value of stress is 63.07 MPa. This is the maximum shear stress. And now we have to determine the planes, means the plane on which these stresses are acting. First of all, we know that maximum shear stress is acting on a plane whose inclination is 45° from the principal planes. So now, as per this relation or as per this concept, we can determine the planes, that is theta 1 is equal to theta P1 plus 45°, and theta P1 we determine 45°. If you add, you will get the angle on which this shear stress is acting. And second, theta 2 is equal to theta P2 plus 45. Theta P2 also determine 96.24 plus 45. Value is 141.24°. So these are the two planes we are getting from these relations, which is the maximum shear stress is acting on these planes. So maximum shear stress will act at theta P1 plus 45, also theta P2 plus 45. These are the two planes the shear stress is acting, which is maximum value. So where theta P1 and theta P2 are the principal planes. So here in this problem we have determined the principal stresses also, major principal stress, minor principal stress. Also we have determined the principal planes on which these stresses are acting, that is the principal stresses are acting. And also we have determined in this problem, that is the maximum shear stress, and exactly where the maximum shear stresses are acting, or we can say the plane on which these maximum stresses are acting. So I hope you understood this problem, which include the shear stresses, principal planes, principal stresses, and also the plane of maximum shear stress. Thank you very much.